All right, once again, welcome to Scalable File System for Video Surveillance. Let's go ahead and get things going. I'd like to invite you to enter any questions you might have in the Q&A button at the bottom throughout the presentation, and Michael will get to those at the end of his presentation. Should be a lot of fun, and without further ado, I'd like to pass it over to Michael Cade, our Consulting Solutions Architect and overall VSS expert.
Good morning, good afternoon, or good evening, depending upon where you live. My name's Michael Cade, and I'd like to talk to you today about video surveillance. You're going to, let's just start at the agenda and then I'll go into it. But what I want to talk about is minimum requirements for modern video surveillance system. I'm going to go into a little bit of depth on what cameras do to video surveillance. And that is germane because of the fact that every time you change a camera, change any attribute of a camera, it changes your storage requirements. Who needs video surveillance, and what does the architecture in video surveillance look like? And ultimately, your storage choice affects whether or not your VSS is successful. And we'll describe why that is as we go through it. And then I'll round out with a demonstration and then Q&A. So let's just get started. So today in a modern video surveillance system, one of the things that we always have to understand is video surveillance is to protect property and people. That is the key goal. And I'm going to keep harping on that and going back to that statement throughout the presentation, because if you realize that that is the most important thing, that gets us over a lot of hurdles. Video surveillance must be fault tolerant, and you shouldn't lose any video. And the storage should be easy to administer and scale without downtime. Now, the reason I say all those things is that they all roll up to protect people and property. If your storage is down, or you have to change administration because you have to add storage, or you have to change your camera types, you're changing your frame rate, and that causes a disruption to your video surveillance, you're not protecting the people and the property. And your storage should accommodate changing camera needs. Let's give an example. You have 1,000 cameras set at a retention time of 7 days. If you wish to change those to 14 days, that doubles your storage. Those cameras could be 1080p. And let's say that you have a change in requirement because of AI that you want to introduce into your camera system, that you want to go to 4K. Well, that's 8 megapixel. 1080p is 2 megapixel. That's a 4x increase, and that changes your storage. For accurate AI, you have to have faster frame rates, and I'll explain why. That changes your storage. All those things could keep you from protecting people and property because of the fact that you have to change your storage, and if you don't have the correct storage solution, then that means that what you have to do is shut it down, move your cameras to some backup system, change your storage, which is a manual process, either through allocating a new LUN or changing out disk drives in your recording servers, and then restarting the system. And potentially you could lose video. So let's talk about cameras in general and what cameras do to storage. We have several things that we look at when we're looking at cameras. We look at the resolution. We look at the frame rates. We look at the scene complexity, and I'll explain that, and you'll see why I talk about that. We look at retention time. And some of these are dictated by legal reasons. You could be going into a court system and you could have video of something that's happened in your environment. And the last thing you want to have happen is that someone can't identify a person from the opposing lawyer's team, a jury, a judge will toss out your video because maybe you have a chain of custody problem. All these things that you want to look at to make sure that you're completely rock solid in your video surveillance. Lastly, I want to highlight a running person is hard to identify if you choose the wrong frame rate and the wrong camera. And that's just as an example, and I'll show you that in a moment. So when we look at resolution, human operators typically have no problem with almost any of these pictures. But can you identify the license plate in the left picture? I just so happen to know by looking at the right one, it's Pennsylvania. But if you were looking at that because your resolution is not high enough in your camera, that would be a problem, and that's hard to identify. The other thing you'll notice is when you look at that person in the left, look at the color around the eyes, look at the cheekbones, look at the chin, look at the neck. Sometimes it's hard to identify who that person is by just looking at that picture. So what about when you do AI? AI can really only identify the one on the right. And that is because it's clear and AI can get a good view of that person. So if you're interested in bringing AI into your environment, you have to start thinking of things like resolution and frame rate. The other one is compression. A lot of times to save on storage, what customers will do is that they'll heavily compress the video. Now, you can change the compression ratio in most modern camera systems, but the codec is called H.264 or H.265. You can select that and you get a very good resolution in compression. Usually it's very low compression, as evidenced by the left. But a lot of people will go into their cameras and change the compression ratio in H.264 or H.265 in order to get better compression, less data transferred, and less data stored in order to save money on storage. But then you get the problem with the right. Can you identify that person? Look at the cheekbones are gone. The lips are gone. The chin is undefined. The hairline is almost undefined. You can't see the ears. So that is a high compression and a poor video surveillance system. You're going to see motion on this. When someone's walking in the top two at 10 frames per second or 30 frames per second, any AI or any person can identify who that is. But the problem that you've got is in the bottom with running. Because someone's running at 10 frames per second, within 1 second, they're out of the frame. With 30 frames per second, I can actually stop those frames and look at them and the picture will be clear. The problem with 10 frames per second is that I will have a blur and it'll look like it's unfocused if I try to stop that at 10 frames per second. If I can do it, because the person's moving through the camera very, very quickly. So again, this is something you want to look at when you want to identify certain areas that you want to look at. Now, 10 frames per second is probably fine within a building. Outside a building, people more likely will move quicker, like running or walking quicker or moving behind objects, and you want a higher frame rate. Here's the scene complexity I was talking about. In modern video surveillance systems, we don't use motion capture anymore. That's a very old technique in order to save on storage. Most modern camera systems created within the last 5 years do what's called variable frame rate. And so what that means is that it compares what it saw in the previous seconds against what it's seeing now, and it will dial down how much data is being sent and changing the scene complexity. And then as the motion changes, it'll dial it up and send more data. So for instance, here's a school hallway on the left, and you can see that it's sending 300 kilobits per second of data because nothing is changing in that hallway. But yet that's not motion capture. That camera is on all the time. It's just not transmitting much data. On the right side now, the bell has rung and the students are moving from one classroom to another, and that camera will dial itself up. The reason you want to do this versus motion capture takes a while to turn on. It's not instantaneous for both the camera and the software to start to recognize. This is the preferred way in modern video surveillance systems, is allow the camera to use what's built in, which is variable frame rate, and that changes the scene complexity. So, this looks a little busy, but bear with me while I describe it. This is 4 pictures of the same thing. So this is a camera calculator. that's available on the internet where you can plug in how many cameras you have. You can maybe see in very small print. It's a 1080p, 10 cameras, H.264. I have median scene complexity, 10 frames per second, 24 hours a day, 15 days of retention. And then that tells me that I need 32 terabytes of storage. But notice now, I change it to 20 frames per second. It doubles it. Again, doubling effect. I change it to 30 frames a second. It triples it. I change it to 30 frames per second and 30 days. It doubles it again from the 96 to 193. So you can see that anything you do in cameras will change how your storage operates or how much storage you need. So who needs video surveillance? Well, you know, when you look at video surveillance and what you need, you'll understand if you're running your own businesses, exactly where you want it, what you're trying to do. Again, you're trying to protect people and property, but look at the different industries that use video surveillance and have to have it. City, state, and federal government, schools, anything from kindergarten through 12th grade, all universities. Police departments, more and more, not only in the buildings, but body cams and dash cams in cars. Jails and detention, water and power companies, public transit, airports, sports venues, casinos, etc. Now, I like to point out that Cumulo's been successful in, I think, almost every single one of these with video surveillance. Ones that are very public, if you will, and that we're quite proud of. We're proud of all of them, of course, but the sports venues, we were selected for the San Francisco 49ers and also the Green Bay Packers to protect their stadiums with video surveillance. We're in airports, we're in public transport, transit, we're in water and power companies for cities, we're in jail and police departments, et cetera. I don't think there's anything on here that Qumulo is not protecting with video surveillance today. This is one that I find very fascinating. AI is becoming a lot more prevalent in video surveillance. And so this is one where I've been talking to this factory of the future. And one thing that a lot of people don't realize who are not in the United States is that in the United States, if you build an airplane, an automobile, a train, etc., you have to keep records as a manufacturer by law for 18 years, not only of the car, but every part that goes in the car. So, or every part that goes in the airplane, or every part that goes in the train. So if there's an accident and the government agency comes out called the NTSB, and they come out and they look at the accident, they'll go, the VIN number on that car is this. A manufacturer, please show me every part and how it was manufactured. This way they can zero in on exactly what the problem was. And they have to show that for 18 years. So what this factory is trying to do is, instead of the paper records that they're now digitizing, they started to take the idea of maybe on the assembly line, what we'll do is we'll take a picture of a good part, completely pristine. This is what it should look like. And then as it's moving down, as the parts are moving down the assembly line, you have cameras that are operating at 240 frames per second, very, very fast. And they're taking pictures and comparing them with AI against the pristine part. If it doesn't match, it ejects it and a human looks at it. If it does, it continues through the phase. And then as that gets loaded in a car, the ID of that part gets attached to that VIN number so that you have all of that within one system. And there's no humans involved in this at all. It's all through AI. As you can see down at the bottom, this manufacturer is looking at about 30 petabytes in order to store that data for one part for a car, which happens to be a battery. So let's talk a little bit about the architecture of video surveillance. This is the same for almost every software vendor out there. The major software vendors are Genetec and Milestone. They control about 90% of the video surveillance market. And then you have VSS, Panasonic, Honeywell, and others. And the reason I bring up VSS here is that they probably control 90% of one specific market, which is casinos and hotels. So we call them casino hotels, put the words together, because this is, although they are used in other places with video surveillance, they've really captured this market because they understand what the market requires for casinos. So all of the regulations that are required for gaming, if you will, they understand that, no matter whether it's Native American gaming, whether it's gaming in Macau, whether it's gaming in Las Vegas, whether it's gaming in New Jersey, et cetera. They understand that market. So let's look a little bit at the architecture. If we start at the bottom, typical video surveillance is have a private 1 gigabit Ethernet network with your cameras on it. It's a switch network, of course. Going into one or more recording servers. Now, I guarantee it's more than one, but I'm just showing one here with its failover to give you an idea of the architecture. Generally, you would put 50 to 100 to 200 cameras on a recording server. So if you have 100 cameras and you've got 3,000 cameras, you have 30 recording servers and some number of failover recording servers. Those go into a 10 or 25 or 100 gigabit Ethernet, where you have the management servers with its failover, the SQL server that identifies where all the assets are stored, meaning where all the cameras, where the management servers, where the recording servers, where's the storage servers, all that's stored in SQL. And then the analytics server, what we would call AI. And then your smart wall or your PCs for your security officers. I've actually been in a facility in Denver, Colorado, where the city has an entire smart wall that is about 5 meters by 10 meters. And it's huge, with about 7 or 8 operators, and they can pull up thousands of cameras simultaneously and put them on the smart walls, and the different operators control sections of the smart wall so that they can actually see, I want to see these 5 cameras and track someone going through the city in a car or walking. I want to go and then take the next cameras in line for the next 20 cameras and make sure they don't turn a corner, or they don't go somewhere or step behind something and they're obscured and they can't be seen. So that is the architecture of video surveillance. Now, let's talk about storage. Storage and video surveillance. What are you doing with video surveillance? Protecting people and property. So when we talk about keeping everything up and running and making it as fault tolerant as possible, one of the things we want to look at is, what do you do with your storage? There is one way that you can do it, and a lot of vendors do this. They just put disk drives in the recording servers. So let's go back to my example of, you've got 30 recording servers, each with 100 cameras. And you've got, say, 50 terabytes in each recording server running RAID 5 or RAID 6. What happens now is that's horribly expensive in terms of administration. People are very expensive. It's a waste of storage. What if you're using 25 terabytes in each one? Now you've got half your storage that's unused. And more importantly, what if you change the frame rate, or you change the resolution, and you start to change this through your environment, and now you end up with a recording server that needs 4 times more storage than the 50 terabytes you have? And what do? I'll tell you. You have to shut down the recording server, fail it over. You have to take it apart. You have to pull the disk. You have to put more disk in of either greater capacity or add more disk in order to handle the load. You have to bring it up. You have to reformat the disk. You have to fail it back and move everything back. And that opens up a potential for loss of video. On top of it, you've got people who are doing that job, and now they've got to do it times 30 machines. Drive rebuilds are horribly slow in RAID 5 and 6. And you want your recording server spending its CPU cycles to rebuild disk drives when its job is to record video or play it back to protect your people and property? And there's no analytics in any of this. Let's look at cheap SAN and cheap NAS. Again, we have an issue here. We're not putting the disk in the recording server this time. We're writing and creating LUNs. But does it look any different to the recording server? I have now created a LUN that's 50 terabytes. The only thing I have not done in the recording server is set up RAID 5 or 6. That's handled by the storage, but everything else, I have the same problems. I need lots of administration. I need to shut those servers down, because what I've got to do now is I've got to increase from 1080p cameras to 4K cameras. And so I have to fail them all over. I have to tear it down. Now, I don't have to open the case anymore and change disk, but I have to go kill the LUN, create a new LUN, put it on there, reformat the drives, move it back, and do that times 30. Drive rebuilds, again, are very slow. Most SANs, not all of them, but most of them, and almost all the NASs have a problem because of the way they do the drive rebuilds and how they handle them. The average is about 1 hour per terabyte. You've got a 50 terabyte LUN going to a 100 terabyte LUN. You're looking at 100 hours to rebuild that LUN. During that time, yes, it's writing and the data's still there, but that's taking cycles on your storage, and it could slow down your recording servers. OS upgrades, the average is 30 minutes. We've seen one NAS vendor that took over 20 hours to do the OS upgrade across multiple petabytes. That's potential of downtime. Downtime equals video surveillance that's out. And again, you're not protecting people and property, and you have no analytics on the storage. So let's talk about Qumulo, what I call the new paradigm. Qumulo is a clustered distributed file system where we start with 4 nodes as a minimum, and we can grow to hundreds of nodes. All data is striped across all the nodes. And we do this intentionally because as we're doing it, we're load balancing, and we're using a new type of algorithm called erasure coding that is much better in terms of failures than RAID 5 or RAID 6. It protects against entire node failures. So when I have a node, and some of our nodes have 12 drives, 10 drives, some of them have 40 drives. And when you have 40 drives in a node and the node fails, that's equivalent to a 40 drive failure simultaneously. What RAID system does that? You can't do it except with erasure coding. In larger clusters, we could have 2 node failures, 3 node failures, 4 node failures simultaneously and still incur other disk failures, and the system stays up and running. We give you full real-time analytics. So I can tell you how much is each recording server writing? What is the throughput? What is the read throughput? What is the IOPS? How much storage is it added over the last 30 days, over the last 52 weeks? And I could go down to the camera to look at that. So not only the recording server, but the camera, because cameras are segregated in each of their directories, and we look at the directories to determine analytics. So there's no magic to this. There's just all kinds of analytics that we do down to the directory and file level that you can use to apply to your video surveillance. So let's talk about it when we have Qumulo in the mix. We have 1 volume, 1 mount point. That gets rid of all the administrative overhead of going and changing anything, and I'll show you that in a second. It's a node-based architecture, which means load balancing is automatic, and when a volume fills up, click, you just add more nodes. And you do this on the fly. So I can literally go into my rack, plug a node in, whether that be a 5th node, a 6th node, a 7th node, whether I want to do all 3 at the same time. I plug them into the network, I power them on, and the cluster will come up and say, I've discovered 1, 2, or 3 more nodes, or 5 nodes, or however many you're adding. Would you like to add them to the cluster? And when you click yes, it starts load balancing and moving everything across the 7 nodes instead of across the 4 nodes without ever shutting down video surveillance. And you've never changed anything to grow those LUNs because there are no LUNs. It's 1 volume and 1 mount point. So if you need 50 terabyte recording servers that go to now 3 times higher or 4 times higher in capacity, you don't have to do anything. You just add more storage to the cluster, and you never touch a recording server. It just grows into the new storage. We have handled drive rebuilds in a completely different way through our use of how we do block-based drive rebuilds with our erasure coding. So we can rebuild drives anywhere from 2 to 6 hours at the longest, and we could rebuild multiple simultaneous drives at the same time. Our entire cluster can update the operating system in less than 30 seconds. That is well within the margin of any failover that is required in video surveillance. So almost every video surveillance in the world will buffer the data before it writes it to storage, or it can buffer in case the storage is missing for a period of time. Well, they're missing for a period of time is usually a minute or less. We're doing this in a lot less than a minute. So to the video surveillance, we've never even disappeared at all. You've upgraded the entire cluster, no matter how many nodes there are, and you don't have to worry about not being on the latest software. It just all works. And as I talked about, we have full real-time analytics, and I'll show you that in the demonstration. So, okay, let's talk a little bit about what is possible and what it looks like. And I'm going to use a real world example. This is a university where we've actually installed our video surveillance on thousands of cameras. And in the data center, I have the management server, I have the SQL server, I have the Qumulo cluster. Also in that same data center, I have a recording server with cameras protecting the building, the IT data center. Then on a campus building, I have a recording server with cameras. I have the security and campus police, which are off to the side, still in the same campus, but in a completely different building. I have another campus building. Of course, there's many, many campus buildings here, but for real estate reasons, I'm only showing you 3 or 4 of them. So it's possible to do complete direct storage from the recording server. So in other words, when the recording server is writing, it just writes to the storage and everything's fine. Now, I've been in video surveillance for many years, in addition to storage. And one of the things that I like to do when I build video surveillance systems is make them as fault tolerant as possible. You don't have to do this if you're a customer protecting your people and your property. As you see, I'm very strong on that, protect people and property, which means that you've got to be as fault tolerant as possible. So one of the things I like to do when I design these systems is I like to say, maybe what you want to do is protect against network outages as well. So what I'll do is I'll record from the cameras into the recording server for say 1 to 6 hours. I'll use 1 hour as an example. And so I put a minimum amount of disks to handle the 100 or 200 or 300 cameras on that recording server. And all I do is mirror it. So for instance, maybe I'll put two 2-terabyte SSD drives in there for a total of 4 terabytes. And I cookie cutter that recording server across the entire campus because that's all I need. I'm going to record 1 to 2 hours. This way, if the network here, this 10 gig network, goes down for a period of time, I've got some time to figure out what's going on with the network and bring it back up and running, and I've not lost any video at all because the recording server is local to the cameras and the recording server is still grabbing the data off the cameras. Now, maybe my campus police are not looking at the video, but I've still got it for legal reasons to protect my people and property, to go back in history and look at the video. Now, after 1 hour, the recording server software automatically aggregates it into the Cumulo cluster. Now, this is not archive, it's an aggregation. And my campus police can say, I want to look at the last hour, and it will come from this recording server because that's where it's at. I want to look at 2 hours ago or 3 hours ago or 4 hours ago, it would automatically come from the Cumulo cluster to the campus police. And there is no difference in terms of performance. In fact, I would submit it's faster coming from the Cumulo than it probably is from the local disk. If I'm building complete fault tolerance, I'll be honest with you. What if the recording server goes down, and I don't have enough failover recording servers? Maybe I built 30 recording servers and I've got 2 failovers and I've lost 2 of them and the failover recording servers are in use. Well, what I also like to do is if this network goes down from the cameras, maybe I put an SD card in every camera. All modern cameras have an SD card slot. And so what happens now is the recording server software for Milestone, Genetec, almost every modern video surveillance software will recognize that data is stored on the SD card, and when the recording server comes back up and running, it not only takes the live feed, but it dumps everything from the SD card and slots it into the right time slot, so that when it pushes it up to the Qumulo or your aggregated storage, it's already in its right time slot and it's in order, so you don't get anything out of order. So you're protecting against camera network failures, you're protecting against recording server failures, you're protecting against 10 gig network failures. You're buying storage that can handle 160 drives failing simultaneously on larger clusters, that can lose power supplies, networks, CPU cards, storage, disk drives, all those things, and the storage doesn't even hiccup and keeps on going. So let me take a pause right here. I'm going to grab a sip of water, and then I'm going to give you a little demonstration of how this all looks. So let me jump to the back. Here is the Cumulo. And this is the a cluster running in Seattle, Washington in our corporate offices. And before I start, let me show you what the cluster looks like. I have 6 nodes of 104 terabytes per node in this cluster. That provides 485 terabytes of total usable capacity. If I look at any node of a cluster, I see it has some amount of HDD and some amount of SSD or NVMe. We just call this the flash tier. This provides very high speed writing. Every hybrid node in Qumulo has some amount of flash in every single node, so that as writes come in, they stage to the flash tier, they get acknowledged because they're safe stored, and then at some later point in time, they're all tiered off to the spinning disk, so that you get the economics of lower cost spinning disk, but the performance of all flash. And that's built into every single Qumulo product. You can see the status is green, so everything is healthy. All my power supplies, all my motherboards, all my disk drives, all my nodes, all my networks, all up and running. You'll also see here, this is a summary of all the analytics for the system. And there are detailed analytics in different screens up here that I can go into. But when I look at the summary, I just start at the top and briefly go over them. This cluster is 16% full, and it's composed of data, metadata, snapshots, and how much is available. On the right, you can see how many files, and on my adding files or deleting files. So how many files I've got, how many directories. I've got my histograms of IOPS, throughput, and latency, and I can change the time frame and look at them at any point in time. So I can come out here at, say, 9:30 last night and come along and actually go and put the cursor here and then go to the right and look at the numbers and see what happens. If I move to the far right, it's real time. So I can see that right now it's reading at 1.75 megabytes. It's writing at 984 megabytes per second. Remember, storage is in bytes, cameras are in bits. So there's an 8x difference. I'm actually writing 8 gigabits per second or 1 gigabyte at the moment. These nodes in Qumulo can all do about 1 to 1.5 gigabytes per second, depending upon the model, of writing for every single node. So in these 6 nodes, let's just say it's 1 gigabyte per second. I'm getting 6 gigabytes per second of total throughput, or 64 gigabits per second of total throughput. What is read distribution? What is the write distribution? Looked at over 24 hours. What about the loading on the nodes? What are the mount points? Who are the most active clients? And then down at the bottom, trending. In the last 72 hours, how much has my data grown or shrunk? And which directories cause that to happen? Now let's equate this over to Milestone, which is what I've got in my lab. You're seeing here the Milestone management software, and I see that I have 7 recording servers running some amount of cameras. Now, I'm running 500 cameras. We don't have 500 cameras in Qumulo, and to be honest with you, in my lab, even if we had real cameras, I wouldn't show them to you, right? That's just a security violation. So what I'm doing is I'm running a piece of software in another server that simulates cameras. So to the Milestone software, to the Genetec software, to the Mirasys software, it looks like there's real cameras that it's talking to. But in reality, they're all simulated cameras with pre-recorded video. And I've set them up so that every recording server has the same cameras, if you will, to that one. So if you were to look down here, you'd see that they all look the same. Now, let's look at the storage. I have here the first tier of storage where I'm recording 1 hour to 190 terabytes. Why 100 or 190 gigabytes? Why 190 gigabytes? I only have a 200 gigabyte mirrored SSD in this unit. So I'm handling up to 75 cameras. You can see that down here. I'm handling up to 75 cameras in this recording server on 190 gigabytes stored within an hour. Then to the Qumulo, I have your UNC path that goes to a mount point in the Qumulo. I'm saying store for 30 days for 30 terabytes. And I'm actually saying every hour, move that data from the first tier to the second tier and aggregate it on the Qumulo. So that drains down this first tier that's on the recording server and aggregates it on the Qumulo. Now, if I were to go look at it and I'm a security officer, here's what I'd see. So I'm looking at right here, 4 cameras, and you may see some jerkiness because what's happening is I'm not in Seattle, Washington in our corporate office. I'm in a field office in Scottsdale, Arizona. So I'm coming across a high latency WAN network, 50 milliseconds. I'm looking at these and then I'm going out Zoom to all of you, which is another high latency. So you'll see motion, but you may see some jerkiness in the motion. And trust me, this is very smooth because these are all set at 30 frames per second. Now, right now I'm doing live. Let's hit playback. And one of the things I'm going to do is I'm going to select the time frame. And the time frame I want is from the, let's say from the 12th to the 13th, meaning 2 days ago to yesterday. I'm going to look at a 24-hour period. I'm going to say, okay, and then I'm going to say play. And now you're going to see that nothing's changed in terms of the video. It's all coming in. We've got everything moving. And if I come over to the Qumulo, you're going to actually see that I'm reading at about 1.5 megabytes per second while there's 857 KB because I'm only looking at 3 cameras or 4 cameras that are coming in. Let's look at a little bit more of the analytics. I want to look at all the hotspots. This has to redraw the screen. It redraws every couple of seconds. And so what I see is if I rest my cursor there in this directory tree, I see I'm doing about 27 megabytes per second. In this recording server, you see that I'm doing about 12 megabytes per second. And in this recording server, I'm doing about 11. In this recording server, it's actually got some cameras that it's reading from. Notice the name is in hex. That is a protection mechanism within Milestone. Not all software has this. I would go to the Milestone console and have it identify the recording server. It would give me a hex key, and then I could put that against the data that's stored in the Qumulo. So I would know exactly which recording server that is. That's so that it prevents anyone from looking in the storage and going, oh, I want to zero in on the recording server, and I want to zero in on the camera, and I want to just go right to them. You would have to go to the Milestone console to get the key before you would understand what you're looking at. And it prevents someone who is not cognizant with Milestone or has access to the Milestone server from being able to just look at the data. I want to be able to look at a client and I see all the clients and I see all their throughput. So you see here, I'm doing some reading. It's in purple and it's very low. I'm going from 4 different recording servers. And if I open it up, you can see all of the assets that are being read. You may not notice there are path names in there. There's /milestone. Then you've got the recording server up to the /. Then you've got, and then you've got the camera up to the next / with the block suffix on it. So we're getting blocks back from that camera and putting it back out to this display so that you actually see this. And then I could come along and say, oh, I want to look at maybe one camera here. And so this is, again, being fed off of that from one day ago, because everything is in playback mode right now. So I'm looking at one camera in a mythical library, because remember, this is a camera simulator. So you actually see that I'm going to get right here in AC11, I'm getting actually some reading and writing simultaneously. It's coming from that camera. And here's the two where doing reading. There's all kinds of analytics I can look at, like trending. How much has the storage grown over weeks, days, or hours? And when I look at hours, I see the line. Here I started 72 hours ago and I had 41 terabytes. And now 72 hours later, I've got 78 terabytes. And you can see this steady growth going up. And then you can see how much was added every hour, hour by hour. And if I click one and come to the bottom, you can see exactly the recording servers that brought in the data. Again, it's coded with that hex number, but it's easy to go to the Milestone Console and actually look at that and see which recording server did it. That's pretty much my demonstration. Hopefully you get an idea of Milestone, although that was not my intent, is to just zero in on them. That's what I have in my lab. And you see this against the Qumulo and what it is that you're looking at. So with the Qumulo, you can do all different kinds of things, from replication, all the data is encrypted, the 100% fault tolerance. I can put quotas on. I can use it for NFS as well as Windows workflows. By the way, I think about 100%. I'm not positive on that, but I'm pretty close to positive that about 100% of all video surveillance workflows in the enterprise are all Windows-based, and that is because of Active Directory and the protections you get there. I can do snapshots, replication. I can read and write to S3. There's all different things that you can do. I do a full audit trail of everything that happens within the system. So I'm just going to step back and highlight this one slide. I'm going to answer questions now. And if you would, please put them in the Q&A and I'll bring them up. Again, let me just take a short break, take a drink of water here. Okay, so an anonymous attendee said, I understand Qumulo has tight integration with Milestone and Genetec. What about MirrorSys? Are any current customers running MirrorSys off the Qumulo cluster? So we are fully certified with Milestone, Genetec, and we completed certification with MirrorSys in their labs near Salt Lake City, which is the United States lab. We completed the certification, and we're currently trying to make them an OEM. So they may actually resell our hardware and software. So to say the integration is tight is an understatement. MirrorSys has probably gone one step farther than both Milestone and Qumulo in terms of all the failure scenarios they tossed at it. Now, the second point to your question, is there any current customers? No, there aren't. We're working on a couple together, but as you may or may not understand, in video surveillance, typically there are much longer sales cycles. So, you know, we're just working on a couple right now, and we're in contract negotiations to potentially have them be an OEM. So those are ongoing. So next, anonymous attendee, can I use Qumulo to optimize my video surveillance environment? I'm constantly adding cameras and not sure when I need to add another camera server. That is a great question. And you can see with the analytics, you asked the question before I went through the demo. Hopefully you saw with the analytics, I know what every camera is doing. I know what every recording server. If I come back to this screen, I know the growth over a period of time, whether that's hours, days, or weeks. And I know when this cluster is going to fill up. So I can actually see the growth and know exactly, and we can give you an alarm and alert that says within 30 days, this cluster will be full. So you can make decisions now as you're adding cameras, or you're changing frame rates, or you're changing retention times, or you're just changing a camera from 1080p to say 4 megapixel or 8 megapixel, which is 4K, by the way. And you're doing this, and you could see in this, you would see the trend line grow and how much more steeply it would grow. And you would get a new alarm and alert that would say, you're not going to fill it up in 30 days now, you're going to fill it up in 7 days. Then you can start to make some decisions on what you need to do. The nice thing is, you don't have to do anything to the storage. You don't have to do anything to the recording servers. Add your cameras, change your frame rate, change your resolution. All of that's just going to work. Now, admittedly, you may overload your recording servers because they're slated to handle, say, 1 gigabit per second or 2 gigabits per second, and you've got so many cameras generating that, and now you've quadrupled the resolution or the frame rate. And so you may actually have to buy more recording servers. But you know what? Use my cookie cutter method, where you buy a recording server, put a minimum amount of disk on it, make it the same amount of disk for every recording server, plug it in, and in the management console, all I do is say, this is the Milestone or Genetec or VSS. I'd say move these cameras from here to here, and it's done automatically. Now the new recording server has got those cameras, and that's a pretty seamless operation. So, next question. Is Qumulo able to record surveillance video to the cloud? I'm going to get, the answer is yes, but that's not Qumulo. That's the recording server software does that, and here's why. Qumulo could do it, but it's legal requirements. And I'm only going to talk about the United States because I don't know about other countries. We have this thing called chain of custody and chain of evidence. If I'm using my video surveillance to protect people and property, and something bad happens, and I take that video and I go into a court of law in front of a judge and a jury and a defending attorney, and I say, here's my video, the first thing they're going to ask is, who's touched that video? And if it's not certified software, Milestone, VSS, Genetec, Panasonic, Honeywell, all of them have gotten certified with the court system. So that basically, when they go in, they say, we're running Milestone software, Your Honor, and here's the watermark in the video, and they all watermark the video. Here's the watermark, it has not been tampered with. But as soon as you've got a storage platform that does things to the video, you could potentially have a chain of custody issue. So even though we could write to the cloud, you pretty much want the Milestone software to write to the cloud. So in other words, set up that tier where it does the first hour on the recording server, aggregates it to the Qumulo, and then have the Milestone software aggregated into the cloud. Because you don't want any software that is not certified with the court system to touch that video and potentially cause a chain of custody issue. Again, my caveat is that's the US. I don't know what the other countries are, and take that and research yourself. Next question. Can you have video surveillance data on the cluster alongside other use cases like file share or backup target? Absolutely, you can. But again, for chain of custody reasons, for legal reasons, make sure that it is in separate directories, with those directories locked down by Windows ACLs, so that the only thing that can look at that share or the shares that you're using, because you can have more than one share. I usually have one share with multiple directories, a different directory for every recording server, but you could do a share for every recording server as well. A share is just a directory. A share could also be one directory with subdirectories under it. So my point is make sure that you set the ACL so that the only person or the only thing that can read and write that is the service account for the Milestone software or the service account for the Genetec software. So that means that when I'm here, what's looking at this for the security officer is the software from Milestone that's reading it, and the ACL is allowing the service account to do it. What's doing it here is the recording servers are using service accounts to write to it. And then my shared data, which is my home directories, my document management systems, my backup targets are in different directories, and no human can go in and say, oh, look at that. I see a milestone directory. Let's go into it. And they're prevented from doing it because of the ACL, and it preserves chain of custody, so you never have an issue with the court of law. So that is the questions that I see on screen. I'll take a 10 or 15 second pause here to see if there are any other questions. Otherwise, we've gone about 52 minutes. And I thank everyone for attending. Hopefully you really got something out of this. You understand a little bit more about video surveillance, pieces, the parts, the components, what it is that you want to do to protect the video surveillance systems and protect your people and property, and why storage, a very good storage system, is very, very important in this. Don't go buy something cheap just to keep the costs down. Buy something that keeps your people costs down, keeps your video running, protects your people and property, doesn't get you into chain of custody issues with the court of law. Make sure that everything is running and running well. So I see there are no more questions, and I'd like to thank everyone for coming. Jonah?
Thank you, Michael, and thank you everybody for joining. This was really fun. Look out for the webinar recording to come into your email. If you have any more questions about Qumulo for VSS, please reach out to your sales rep or reach out and we'll get you connected. Thanks so much for joining, and look out for that recording. Have a good one all. Bye-bye.